What's up, everyone? Let's talk about mixtures and weighted averages. It's actually an interesting content area because it's not super represented on the real test. You're not going to go into the exam and see 4 mixtures questions per quant section like you would with something big like geometry or like triangles, even a subset of geometry like triangles. You're going to see triangles every single time you take the exam. You're probably not going to see mixtures questions every time you take the test. Out of the official tests I've taken, I think it's about a 50-50 hit rate. I've probably seen a mixtures questions once every 2 times I've taken the real exam. So if you feel like you don't have a great strategy that really resonates with you for these problems, that's actually not the end of the world. You could absolutely get away with never being great at mixtures questions and still get a really amazing quant score. I am going to give you a couple approaches that I think are phenomenal, so I think we'll fix any of the issues you have been having with these in a moment. But I have noticed there's a certain type of student who's just not going to click with mixtures questions. It's just a really painful thing for certain kinds of people, and if that's you, I want you to know you're not alone, and it's okay to just delete and randomly guess on mixtures questions on test day. I know that might sound like complete insanity to some of you, but I've helped tens of thousands of people with this thing at this point, and I'm giving you my honest opinion from a perspective of really genuinely caring about you and your success. Now, let's at least give you the opportunity to be great at these by talking about a couple of what I personally feel are the top approaches that you're going to get the best results with. First thing is just starting with the basics. Memorize the weighted averages formula. It's the same thing as the mixtures formula. I don't know why more people don't use this approach to these questions. I won't say it's simple, but it's very foundational. It's just you memorize the formula, you plug and play, and bam, you're going to grad school. Now, there are a ton of different ways to organize this formula. I'm going to give you the one that I like, that I use the most, and that I encourage my students to use as well. I would say 95% of the time. That starts with part of A times quantity of A. So this would be like a percentage or a ratio or something like that. This would be like pounds or quarts or whatever, and I'll show you exactly how this is going to play out on this problem in a second. But just to make this make some kind of sense before I rock through the whole thing, where you might be thinking, what? Part of A? What does that mean? Okay, so this is going to be some kind of quantifiable amount, and this is going to be some kind of percentage or fraction or some kind of part. Then we'll add that to the part of B times the quantity of B. And what that gives you is the weight of each thing in the mixture. It's the actual total amount multiplied by the percentage or part that is actually being mixed together, okay? Hopefully that makes sense, and if it doesn't, don't worry about that. You can still get these problems right even if you don't understand the theory behind a formula like this one. And what we're gonna do is just make that equal the part of A and B together times the quantity of A and B together. And I think showing you how this plays out on this particular example problem is probably gonna be the best way to get this kind of thing to connect. So let's do that. I'm assuming you've read the problem, but go ahead and pause and read it if you haven't. It's a classic mixtures question. This thing has this part ryegrass, this thing has this part ryegrass. If we put them both together, it literally says the word mixture. We get this much ryegrass. And then they're going to just ask you whatever they want. There's a few different flows and flavors they can ask you about here. This one is asking what percent of the weight of the mixture is X. Now, part of the reason I'm going to recommend that you just memorize this thing is you're like, oh, cool, a mixture. I got a formula for this. So you just start plugging and playing. So part of A, that's 40%. They tell me right here. Seed mixture X is 40% ryegrass. That's a part. And now it doesn't tell me how much X is in the mixture, so I'm just going to make a variable there and call it X pounds or X quarts or whatever. Then I'm going to add to that the part of B. It tells me that's 25% ryegrass. So I'm going to go ahead and depict that this way. And then what's the part of A and B together? It's 30%. They told me that. And then the total quantity of X and Y together is just X plus Y. So what I like about this is it turns it into just a standard algebraic translation, which I think is a lot less like of a mental baggage thing. A lot of people have a lot of mental baggage about mixtures and weighted averages. It's like a troubled past with them. And again, like I said at the top of the video, if that's you, that's totally fine. Just accept it, try this out. If it works for you, great. If it doesn't, no big deal. But if you can get to this point, then you've got a real fighting chance on this problem, because what percent of the weight of the mixture is X? you could just use a standard algebraic translation approach for that, which is x over x plus y times 100. That's going to yield the answer that we're looking for, okay? There's a lot of different ways to figure that out. So let's go ahead and grind on the math here. If you're going to end up using this formula a lot, a really great thing to keep in the front of your mind is multiplying both sides by 100. It tends to work out well when you've got percentages in the mixture. And if you're seeing mixture questions with percentages, you're always going to have percentages on both sides of the equation if you use this equation. So I'm going to multiply by 100 on the left. So that's going to give me 40x here and then 25y here. I'm going to multiply by 100 on the right, and that's going to give me 30 times x plus y. And already I think that makes the math a lot more approachable. Let's go ahead and distribute our 30 over here. So 30x plus 30y and then 25y, 40x. And now we'll just combine some like terms. So I'll subtract 30x from both sides. I'll subtract 25y from both sides, and I'm going to get 10x over here, and I'm going to get 5y over here. Now, some of you are good logical deducers of things, and by the time you get to this point in the problem, you're already seeing that y is twice as represented as x, and you're going straight for the right answer, which is B. The vast majority of you are not making that connection, okay? So let's go to the next step. Let's divide both sides by 5 to just simplify as much as possible, and we get 2x equals y. Now, what I'll encourage you to do if you're going to take this pure algebra approach is translate the question in terms of algebra and then just substitute in right here. Let me show you what I'm talking about. So here I've got x over x plus y times 100. Well, I know now that y is the same as 2x, so let me just substitute in there. I'm going to get x on top over x plus 2x on the bottom times 100, and that should give me my answer. So if I just run the numbers here, I'm going to get x over 3x times 100, and then the x's cancel out, and I get 1/3 times 100. Well, what's 1/3 times 100? Boom, 33 1/3%. Okay, so that's my preferred route through the problem. It's heavy on visual organization, which if you follow any of my stuff, you know I'm a huge proponent of. I think you should always be auditing your visual organization because it's just so critical to stop missing questions you know how to do. If all of you just stopped missing questions you know how to do right now, you're probably looking at another 30 to 50 points on your overall and like 3 to 5 points on your quant subscore, which is massive. That could be the difference between 100 grand a year and 200 grand a year post MBA. So just do the math there. Now, despite my recommendation, this just might not resonate with some of you, and that could be partially because you don't like the whole formula thing, or it could be partially just the way I executed the math here. So I want to be clear, I don't really have an attachment to how you execute this particular math. If the formula works for you, but you like to do the solving and the reasoning a little bit differently, that's completely fine. Roll with it if that's you. If you dislike the formula, or you're thinking that's never going to work with me, I'll show you an alternative in just a moment. But I'm also going to talk about some of the virtues and the vices of that alternative. Let's quickly talk about the virtues and vices of this particular approach before we move on. Now, the virtues of this are it's simple, you just memorize it, plug and play, and you don't have to be an amazing creative problem solver to get it to work. It's nuts and bolts, you run the numbers, you get a result, and even if you just get here and get stuck, you've still got a pretty good shot at guessing what the right answer is probably going to be. You could probably logic your way out of A, C, and D at this point and have a pretty good 50-50 shot, which is pretty nice considering you just might not be able to make this particular connection. That's cool. Now, the vices of this are there's definitely a lot of opportunity for error because there's a lot of steps here and you're doing a lot of percentage math or decimal math. And some of you are just going to really struggle with that. The other downside here is it's heavy on algebraic translation, and some of you are going to really struggle with taking words and turning them into math, even if you have a formula memorized. And if that's you, let's go ahead and pivot and talk about a different approach. And the way I like to think about this approach is start with the regular average and then compare that to the weighted average. And you're going to want to do this very visually in most situations. The way I like to think about this alternate approach is starting with the regular average and then comparing that to the weighted average. Let me demonstrate. I'm heavy on a visual way of doing this, but some of you might prefer a more logical, internalized way of thinking about this. It's the same concept though at the end of the day. So let's think about the regular, or what I might call pure average, between something that's 40% ryegrass and something else that's 25% ryegrass. So I got x over here is 40%, y over here is 25%. Now the pure average, if they were equally represented in the mixture, would be this plus this over 2. That's just a standard non-weighted average. So here we would get 65 over 2, which is going to yield 32.5. So the standard average here, if x and y were equally represented in the mixture, would be 32.5. But that's not the weighted average. What they're telling us is, in reality, the final mixture is only 30% ryegrass, which you'll notice is closer to y. And that means y has a larger weight in the situation. Y has more gravity to it. It's pulling the average down toward its y-ness, toward its 25-ness, because there's more of it in the final mixture. So how does that help us? Well, if you're the slash and burn guessing type, then you're looking at x thinking there's got to be less x in the mixture. So you're thinking it's definitely not D and it's definitely not E, and A is just way, way, way too small. If there was only 10% x and 90% y, then we'd be a lot closer to 25 than we are right now. Now, I'm not a huge proponent of these kind of slash and burn guessing and logic strategies, but there are some of you out there that are going to really resonate with that kind of thing, and so I do like to present it as a potential. What I like about this is I've got a 50-50 shot on what otherwise would be a pretty challenging problem in probably less than a minute, maybe 30 seconds or less, which is a lot of upside for a very small investment. So that does create a pretty attractive ROI. The downside is a lot of you aren't going to be able to pure logic your way all the way to B with 100% certainty. So that's part of the reason that even though I used to favor this kind of approach a lot, I've really moved away from it with a lot of my students over the past decade, and myself included. I tend to just personally go for this because it's less error prone, and I'd rather have 100% certainty just investing an extra minute than having 50% certainty and saving that minute down the line. I've just noticed for myself and for my students, they just get higher scores when they stick to the thing that works for them. Now, there is a way to get all the way to B using this kind of logical approach, but it's really conceptual, it's really heady, and it's probably not going to click for most of you, but I'll just walk through it just in case it's something that resonates. Now, what you can do for this approach is actually just ignore the regular average and focus only on the weighted average. And you can either do this next after going through the rationale I just showed you, or you can just default straight to this. Both ways work. And you look at the weighted average, and then you just look at the distance between this thing, which is +5 over here to y, and the distance between this thing, which is +10. So the actual weighted average is twice as far away from x as it is from y, which means there's twice as much y in the mixture, because in order to get that separation of being doubly far from x, there has to be twice as much y in the mixture itself. Y has to have twice the weight that x has. Otherwise, the weighted average should be equidistant from these two parts. And it's clearly not. So that gets us straight to the ratio that we solved for in our original formula method, where there's a 2-to-1 ratio of y to x. And then what you can do is just transfer that into a fraction. And the way to transfer a ratio into a fraction is you do the part of the ratio over the sum of the two parts of the ratio to get the whole for the fraction, and that gets us 1/3, which is the same as 33 1/3%. But again, that's very fast, and it's very slick and very cool, but you really want to be honest with yourself. Does that really resonate with you? Is that something you can believably see yourself executing on faithfully and accurately in the future? And if it is, by all means, make that your approach. I'm never going to argue with your results. If you're getting great results, do what works for you. Take the test the way that it works best for you. But if you're looking at this thinking, man, I just don't know if that's me. I would love to be the person who could bang that out on the test, but that's just not me. Then you want to just go for the formula method. If both ways are great, I gave you my personal take on it. It's really up to you. Take those approaches to weighted averages and mixtures questions and run with them and watch the results come in. If you enjoyed, if you got value out of the video, give us some love, give us a thumbs up, comment below if you have questions. And if you finally want the structure that's been missing from your studies so you can overcome all the challenges of work and family and lack of time, lack of discipline, lack of motivation. If you're feeling stuck in your studies, if your score's going down, go ahead and click the link anywhere around this video, and we'll be more than happy to show you what's missing. Reach out anytime. I'll talk to you soon.